Good evening, friends. Today we will be understanding the ridge regression. So, we have already studied the normal linear regression. Then why we need this ridge regression? The only answer is the overfitting. Overfitting. Overfitting means what? Our model performs better on the training data set, but our model does not perform better on our test data set. So, but we need a model that will be generalized. For example, what? It works better on the trained data set generally, and if I show him some unseen data, then also it gives a good accuracy. So I have to fulfill this condition. This is the required condition. So for this, what happens is, in the normal linear regression, the cost function used and the ridge regression cost function tells me the difference. For example, let me tell you the ridge regression cost function. Okay, this is nothing hard, it is so simple. That is the mean squared error plus lambda times of summation j is equal to 1 to n and our beta j square, where beta is the coefficient of our independent feature. So here I have to do two things. What I have to minimize this cost function. For this, my mean squared error, this will be normal. We all know this formula, that 1 by n summation I is equal to 1 to n real value minus predicted value square. Okay, so I have to minimize this. So for this, what purpose? I have to just make this thing minimum, because I am going to add this in my mean squared error, and if this value will be small, automatically my answer will be the smallest possible. So let me teach you. Suppose I have lambda can be what? Lambda can be 0, lambda can be between 0 to 1, lambda can be also between 1 to 1 to any value which you want. Okay, so let me teach you. For example, if I take normally lambda 0, so what will happen? My cost function will be equal to MSC. This will be in the case of my normal simple linear regression. Now see, if I choose a small value of lambda, we know that if I choose a small value of lambda between 0 to 0.1, and we all know that when we multiply 0.1 with 2, we will get what? 0.2, and when I multiply 0.1 with 3, I will be getting 0.3. Okay, now the adjustment of these coefficient parameters, what happens is, if I choose a value of lambda that is small, okay, that is what? That is small. So what will happen? My coefficient parameters will become slightly large. Okay, I am telling you the condition. What will happen if you choose lambda? Suppose I choose lambda small, then what will happen? My coefficients will be slightly large. And if I choose a large value for lambda, then my coefficients will be small. And this is the condition which I am requiring. My coefficient of should be small, so that it reduces the overfitting. So what I will do is, I will choose a lambda value that will be moderate, neither too large neither too small, that is medium. Okay, so that my test error is the least possible. So for this, what happens? We do not have to do anything, everything happens automatically. We just pass a range of lambda values which we think it can fit on the data. For example, any random values. Okay, so what happens is that our regression model take one by one these values of lambda, and it checks the condition where my test error is coming minimum, and it updates the coefficient according to it only. And the best fitting value of the lambda is the value which gives me the least test error. Okay, thank you.